The topic of this section is differential. Let me first repeat differential for a function of one variable, and then we will generalize to a function of more variables. So if we have a function f from R to R, and if the function is nice, that means continuous and has continuous derivative, then we can consider two values of the argument, x and x0, and correspondingly we can consider two function values, fx0 and fx. And this difference delta f, which is f at the point x minus f at the point x0, can be approximated by the differential, which is the product of the derivative f prime at the point x0 times dx, which is the change of x, namely x minus x0. And this is very similar to the equation of the tangent line. If you consider the tangent line, then we have y minus y0 is the slope, which is the derivative, times, and instead of dx, we write x minus x0. So this is the tangent line. Well, and similarly, as for the function of two variables, we have the tangent plane, namely z minus z0 is the derivative of f with respect to x times x minus x0 plus the derivative of f with respect to y times y minus y0. Then we can again approximate the difference delta f, which is f at the new point xy minus f at the old point x0 y0, and this can be again approximated by a similar expression like that, namely fx dx plus fy dy. This is the partial derivative with respect to the first argument, evaluated at the old point x0 y0, and similarly this is the partial derivative of f with respect to y, evaluated at x0 y0. And we multiply by some small change of x and by some small change of y, and we add these two small contributions. Well, and we can easily generalize this to a function from Rn to R. Here we have just n terms, each of them in the form of the product of the partial derivative with respect to 1, 2, 3, and so on variable, times the differential of the corresponding variable. We can illustrate this using the example that we have seen when we computed the tangent plane. You remember? That was the function x divided by y at the point 3, 1. So the differential will be derivative with respect to x, which was 1, times dx, plus derivative with respect to y, which was minus 3. Well, that's it. So this is the differential of this function at this point. It can be used to approximate the difference of function values at the point x0, y0 and at the nearby point. So you see, these two concepts are very, very similar. Tangent line and differential for a function of one variable, or tangent plane and the differential for a function of two variables. And later we will see another item very similar, namely Taylor polynomial. This is exactly the equation of the tangent plane is the Taylor polynomial of order 2. Of order 1, sorry.